I'm Ms. Vung. Today we're going to look at graphs of sine functions. Previously we said that sine is the y-coordinate of the point P as we go around the unit circle. So we're going to sketch it out. So instead of going around in a circle for 0 to pi on 2 to pi, we're going to go out. So 0, pi on 2, pi, 3 pi on 2, and then 2 pi. So it's like we're stretching this unit circle out, and we're going to see what it looks like. So starting at the point 0, we can see the y value there is 0. And as we go up a bit, the y value is the height there. And as we get to pi on 2, we can see that at pi on 2, we reach a maximum y value of 1 because we're in the unit circle. As we get to the second quadrant, our y value is getting shorter and shorter and shorter until we get to pi, and it is 0. So again, we're looking at the y value as we move around the circle. So here we go and become a little bit negative, and more negative until we reach the maximum negative of -1 at 3 pi on 2. And then as we get closer to pi, we become closer and closer. So the y value is getting closer and closer to 0 again. And we could keep going and go back up there, and we could go anti-clockwise. So from 0 we can go clockwise, or we can go to the left. So negative, reaching the negative direction, so going to the left of the x-axis, and we can see that we're going down at that point there. So we can see that this pattern keeps repeating as we go around the circle. We keep going and repeating this pattern. And something that repeat we call periodic. So this is a periodic function. So periodic means that it repeats. And the period, or the bit that repeats, is this section over here. So this section over here we call the period or the wavelength, and it's a distance of 2 pi for this particular graph sine x. And we also we can see that the highest point is 1, the minimum point is -1, and we call the amplitude, which is from the middle to the highest point, is 1. So we measure the amplitude from the middle to the highest point. So not -1 to 1, because that would be 2. Let's have a look at if we had plotted like we did back then when we started learning about linear. We plot values. We could have figured out that when x is negative pi on 2, then sine x would be 1. When x is negative pi on 4, then sine x would be -1 over root 2 when x is 0. So we could have done this and plotted this graph. And we can do the same to plot 2 sine x. So when x is minus pi on 2, well, sine x is -1, but 2 of sine x would be -2. Same thing with the next bit. Negative pi on 4 would mean that 2 sine x would be -2 over root 2. When x is 0, well, if y is equal to 2 sine x, that's equal to 0. So we're multiplying all these values by 2. And we do so, and we try to sketch this to figure out what 2 sine x looks like. So at negative pi on 2, we are at -2, so down here. And then we move higher and higher until we reach 0, 0. And then we get to pi on 2, we reach 2. And we're getting smaller until we reach pi is 0, etc. So we can see that 2 sine x looks like that. 2 sine x has the same period. See this section here. It's still 2 pi, but the amplitude is now 2. What about this amplitude? We call that the dilation, or dilation of 2 we're going from the x-axis. What happens if we have, let's say, 3 sine x? You might have guessed it, it will look like this dark blue line here. So the period is still the same, but the amplitude is now 3. What about half sine x? So half sine x would look like this purple line over here. So again, the period is the same, but the amplitude is now a half. So we can see that the value in front of sine x, the value in front of us, gives us the amplitude. So a sine x would have an amplitude of a. Let's look at the period, 2 pi. Oh, and the amplitude describes the dilation from the x-axis. Let's look at putting a number inside the bracket. What happens if we put 2x? Well, when we put 2x inside the bracket, we would get a graph that looks like that. So it's been squashed that way. Or in other words, it's been dilated by a half from the y-axis. So now the period looks like it is only, when does it repeat? When it gets to pi. So instead of the period being 2 pi, it's now pi. But the amplitude is still the same. See, the amplitude is still 1, but the period is now pi. So it has a dilation of a half from the y-axis. How do we get pi from 2 pi? 2 pi divided by 2 gives us pi. So the period is 2 pi over n, if n is a number in front of x. 2 pi over 2 is pi. Let's try another one. So 2 pi over n. So n this time is 3, so 2 pi on 3 is our period. So 2 pi on 3, that's 2/3 of a pi. See? 1/3, 2/3, 3 over 3. So 2/3 of a pi. So we have our period to be 2/3. So we describe this as a dilation of a third from the y-axis. What about if we have a fraction? So now 2 pi over a half is equal to 4 pi. So the amplitude is the same as 1, but now the period is 4 pi. So it has a dilation of 2 from the y-axis. So notice that from the y-axis, it's always, the dilation number is always 1 over the number in front of x. So 1 over a half is 2. What about negative sine x? Negative sine x will look like it has been reflected along the x-axis. So same amplitude, same period, but just a reflection. Let's do an example. Negative 3 sine 2x. So the amplitude is 3, and the period is 2 pi on 2, which is pi, and it has a reflection. So let's get our y and x axis. How do we do this? Well, we look at the amplitude. So our y, maximum y will be 3, and our minimum will be negative 3. And the period is pi. It doesn't have a domain, so it's not telling us when to start and when to end. So we're just going to do a few values. It doesn't really matter, but at least pi. So we know that sine starts at 0, so we're going to put a dot at 0. And we know that when it ends at the end of the period, so now we put a dot at the end of the period. And now we know that the sine graph looks like it up, down. So it goes through the middle in between those two dots. And the highest point is between these two dots. And the highest point will be the amplitude at 3. But because it's reflected, we have to put the dot down here. It's going to go down and then up because of the reflection. So our next dot is down here. And our next dot, down up, would be in between these two at the highest point, 3. So now we have our graph looking like that by joining the lines and making it nice and curvy. So this graph has a dilation of 3 from the x-axis and a dilation of 1 over 2 from the y-axis, and it has also been reflected in the x-axis. Let's do another example. Example 2, a third sine theta over 2. So we can use theta instead of x sometimes, or t, or other letters. Just bear that in mind. So the amplitude this time is a third, and the period is 2 pi over a half. 2 pi over a half is 4 pi. So again, is there a reflection? No, because there's no negative sign in front of it. So now we draw our x and y axis, and the highest and lowest point is a third and negative a third. Now it's a positive graph, so definitely we're going to go up and then down this time, and we're going to end up at 4 pi. So 4 pi has to be in the x-axis somewhere. So we start at 0, we're going to go up and then down, and then back at the end of the period we reach that point again. We go through the middle, in the middle of those 2 points. We're going to go up to a third pi, halfway there. So halfway of 2 pi and 0 is pi. Put a dot there, and then we're going to go up, down. So there's a point at 3 pi there. And now we join the lines. Let's describe that. There's a dilation of a third from the x-axis, that's the amplitude, and dilation of 2, or 1 over the number in front of x from the y-axis. Example 3. Here we have a domain of 0 to 2, and we are sketching the function t 5 sine pi t. So the amplitude is 5, and the period is 2 pi on pi. 2 pi on pi is 2. Is there a reflection? No. The domain is 0 to 2, so we have to sketch between 0 and 2. So the highest and lowest y value will be our amplitude 5 and -5, and our x value is 0 to 2. So if this is 2, halfway is 1, halfway is 1/2. So we're going by halves here. Now we think about the sine function looks like it's going up, down, up. So between here and here we have 2 dots and 1 dot right in the middle, and then we go halfway of these and we go for the highest dot up there and the lowest dot down here, and now we can join the line. So this graph has a dilation of 5 from the x-axis and a dilation of 1/pi from the y-axis. We can also name the range. Lowest y value is -5 to the highest y value of 5 inclusive. Okay, thank you for watching. I'll see you next time. Bye!